Okay, this video tutorial looks at the mathematical strand of measurement and geometry, and more specifically we're going to focus our understanding on isosceles triangles. So there are a few things you need to know about isosceles triangles. The first is that they have two sides the same length, and the two base angles are also the same. Okay, so the two side lengths are not the base. Okay, but those angles that are created by those side lengths and the base are the exact same. Something else as well is that when you connect the apex or the tip of the triangle with the base in a straight line, this line actually cuts the triangle vertically in half and it meets the base at right angles. And we can see this on our diagram where it's meeting it in right angles here, and so I'll put it there, and also that these little double lines here mean that the lengths are exactly the same. Okay, so those, I guess that theory or those rules are very important when we're looking at problems involving isosceles triangles. And we're going to use those theories now to try and solve a problem here where we need to find the unknown. All right, so here we've got an isosceles triangle. I know it's isosceles because there's two sides that are identified as the same length. Now I know the theory of isosceles triangles is that the two base angles are the same. Here's one base angle, which is 24. So I know this one here is 24. And now I can just use the theory of triangles where the internal angle sum of a triangle is 180 degrees. And therefore I can say 24 plus 24 plus x plus 10 is going to be 180 degrees. If I add my 24s together, I get 48 plus x plus 10 is 180 degrees. I can add the 10 and I end up with x plus 58 equals 180 degrees. I can take the 58 and therefore I'd end up with x equaling 122 degrees. Here are some practice questions I would like you to have a go at about finding the missing angles. Please feel free to pause the video. Once you think you've got the answers correct, continue the video and we'll see how you went. Okay, so let's see how you went. In our first example, okay, we can see that this side here and this side here are the same, which means the base is actually along here, and we know that the base angles are the same, so I can call that x. And I can therefore say that I've got x plus 29 gives me 180 degrees. Therefore 2x plus 29 gives me 180 degrees. Therefore 2x is going to be 180 take 29, which is 151. Therefore x is going to be 151 divided by 2, which is 75.5 degrees. In my second example, I know I've got a right angle here, which is 90, and I've got two sides that are the same. I know inside a triangle, the whole thing is 180 degrees. And if this is 90 up here, that means that this angle and this angle here must be the same. Okay, and that must be half of 90. So this is going to be 45. And this is going to be 45 degrees. And I know that because the base angles of an isosceles triangle are the same. All right. Once I've found that out, I then know this is a straight line, and I can either work it out by going 180 take 45 would equal x, and therefore x would equal 135 degrees. Or I could also go, well, I know that the opposite internal angles, so the sum of the opposite internal angles is equal to the external angle. So I could say that 90 plus 45 is equal to x, and therefore x is equal to 135 degrees. You'll notice, same answer no matter which way you do it.